Hello, this is Mr. Stansbury. I'm going to take you through the notes on variance and standard deviation. At the end of this, you should be able to say, I can find the variance and standard deviation of various data sets. Okay, so let's take a look at what each of those things mean. The variance of a data set measures the average degree to which each point differs from the mean. It's the average of all the data points. So it's basically how far away from the average each piece of data is. Okay, standard deviation of a data set looks at how spread out a group of numbers is from the mean. So it's like here's the mean, and then how far out does that standard deviation measures how far out from the mean each one of those pieces of data is. It is the square root of the variance. Okay, so best way I think to understand this is start taking a look at some information about this. Here's the formula to calculate population variance of the data set, where x1 is the first piece of data, x2 is the second piece, x3 is the third piece, so forth and so on. So population variance is this little O squared here, I call that super O, is the sum of the numbers starting from 1 up through n, where the first piece of data here is x1 minus the this little mu here. I think that's what it's called. I can't quite remember. It's the population mean. Okay, and then n is the number of data values. So this is the mean of the population, is this thing here. So you take all that and you square it and divide it by n, the total number of data values, and that gives you this, which right now is not going to make much, if any, sense at all, and that's okay. We're going to make it make sense here in a bit. Okay. With that, standard deviation is simply this formula here. Just take the square root of all of that, and that is the standard deviation. So it's kind of it's just a little bit different way to measure some of the data. Okay. Now, since extreme values, numbers that are far away from the mean, will give large values for this thing here, or this value here, the standard deviation is only useful if the distribution is approximately symmetrical. So as long as the data isn't like all skewed to one side or the other, then standard deviation should be okay. All right, all the stuff that we're going to look at is going to be okay to use for standard deviation. Okay, let's take a look at an example here to help us try to better understand what's going on here. So find the population variance and standard deviation for this data set right here. Okay, so if you'll remember, we have to find the mean. So let's just simply add those all up and then find the average of that. Okay, so we can do that here on our handy dandy calculator. 6 plus 11 plus 10 plus 5 plus 8. Right? So we add those all up, and there are 5 pieces of data, so we divide that by 5, and we get that our mean is going to be 8. Okay, so this right here is going to be 8 each time. All right, so what's probably going to make this easiest on us is to just make ourselves a little bit of a table. So I'm going to make a little table over here, and then we're going to use that to help us organize all of our data to calculate this population variance. Okay, so here's a table that we can use here. So here's all our pieces of data, and then so now we got to find the difference between each piece of data and the mean. So 6 minus 8 is going to give us -2. 11 minus 8 is going to give us 3. 10 minus 8 is 2. 5 minus 8 is -3, and 8 minus 8 is 0. Okay, and then now what we got to do is we got to take this piece of data here, we got to square it. So -2 squared is 4, 3 squared is 9, 2 squared is 4, -3 squared is 9, and 0 squared is 0. All right. So then the last thing we want to do is we want to total all of these numbers up here. So that's what? 13 and 13 is 26 is our total for that. Okay. And then our last step here says we take this, so that's what we've just done. We took the difference for each one, difference for each one right here. And then we squared it, which is this right here. And it's the sum of all those. That's the 26. And now we're going to divide it by n, the number of data values. So then we would just take this 26 and divide it by 5. And that's going to give us what? 5.2 is going to be our population variance. Okay, that's 5.2. Okay, and then now to calculate the standard deviation. So let's see, this is the population variance. Okay, and then to find the standard deviation, we simply take the square root of 5.2. Okay, so we do that. Square root of 5.2, and that gives us 2.28. Oops, let's put that over here. Equals 2.28. Okay, would be the standard deviation, and that on average is how far away the each piece of data is from the mean on average. Okay. All right. We're going to look at another example, but before we do that, let's do a quick little comedy break.
She gives him the phone. He has no idea there's a camera in there. He's just whipping it all over the place. I'm seeing his face zip by at the speed of light. I'm yelling, "Stop moving the phones! Aim it in one place!" He thinks it's for audio reasons. He aims it at the corner of his room. I'm seeing a cobweb dangling. "Can you hear me?" "I always could hear you. Aim it at your face, Dad." So he sort of gets it, but not really. It's like two unfocused eyes. They don't know where to look. Like an alligator coming out of a swamp at a 45-degree angle. I'm like, "Hey, Dad, how you doing?" "Who is this?" "It's Brian." "Who am I talking to?" I felt bad until he asked, "Who's that in the square up in the corner?" "That's you, Dad." "No, there's somebody in the corner looking at us."
All right. Let's see. Let's take a look at another example here. Okay, so example 13. Estimate the standard deviation for this distribution of test scores. So we have all this here. Here's our test scores, and here's our frequency. Okay, so again, we're gonna have to find the mean so that we can calculate all of this lovely stuff, right? Okay, so what we're gonna do for this is we're gonna put the mid-interval value in here. So I just kind of created an extra column here so we can find the middle of this, so that we can take that and multiply it by the frequency so we can calculate our mean, right? So middle of 0 and 9 is 4.5. Middle of 10 and 19 is what, 14.5. So you can see we're going up by 10 each time. So 24.5, 34.5, 44.5, so forth and so on. Okay. Now we got to take this multiplied by the frequency of each one, right? Just like we've done several times before, so that we can figure out what our total is going to be, so that we can calculate our mean. Okay. Okay. Now we can go through and multiply these all out, add them all up, and calculate everything, or we can actually do all this stuff on our graphing calculator. So I'm going to show you how to do that as well. So you can do it by hand, or you can do it on graphing calculator. You're probably going to find it's going to be a little bit easier to do this on the graphing calculator. So first thing we do is hit Stat. We're going to edit, and then what we're going to do is we're going to clear this out. So we highlight list 1 and clear, and then what we're going to do is we're going to put all these in list 1. And we're going to put all our frequencies here in list 2. Okay? Okay, so here's all of our data. There's list 1, there's list 2, all entered into the calculator. So then what we're going to do is we're going to calculate. So we do stat, and we're going to calculate. And now there's still just one variable. It's just the test score. So it's one variable, stats. We're going to push enter. And our list here, all of our data is here in list 1. And then our frequency list is actually going to be this list 2 that we put in here. So then what you got to do is you got to find the L2 button, which is this one right here. Okay, so oops, let's see, we got to do, that's the blue, so we do second and then L2, and then now it knows that the frequency is in list 2. Go down to calculate, push enter, And it gives us that our mean is about 75. And then the sum of all those numbers is 55, 53. The sum squared, so forth and so on. And then look, here's our O, our super O x here. This here, 17.9, is our standard deviation for this thing. Okay, so 17.9 is our standard deviation that we calculated out on our graphing calculator. Okay, and if you'll notice, just to kind of take note here, it also gives you the 5-number summary, the minimum quartile 1, median quartile 3, and maximum as well. Okay. Yeah, so that, once you put that all into the calculator, it becomes a lot easier than calculating this all out by hand. It still can be done, but probably a little bit nicer way to do that. Okay? All right, that's all we have here for variance and standard deviation. If you have any further questions at all, please feel free to ask in class. Thanks.